Alright, so in this video, what we're going to be doing is we're going to be taking a look at this linear transformation from R3 to R3 with the standard matrix given as below. And our goal in this video is to show that this linear transformation is injective. And if we recall from the activities, what it means for a linear transformation to be injective means that given any element in the codomain, so T goes from some copy of T takes R3 to R3, and if I have a vector here in R3, there's only one vector hidden in it, right? There's not a second vector or infinitely many vectors that can hit that point. In particular, what this implies is that in order for T to be injective, what we're trying to show is that the kernel of T is just the zero vector, right? If I look at this transformation here, there's no other vector going to the 0, 0, 0 vector other than the kernel. So in other words, if I were to turn this into some sort of augmented matrix, as such, I would solve this matrix and find a unique solution, the 0, 0, 0 solution. And so let's go ahead and reduce row echelon this thing. And I'm going to go ahead and note that I really don't need to do anything with the last column, right? If the last column is all zeros, then any row operation I could possibly do would still preserve that the last column is all zeros. So I don't even need to bother recording that, right? Minus 2, minus 3, 3, and then 2, 3, minus 2. Let's go ahead and evaluate this. And if I do that, I get the identity matrix, right? So if I call, let's say this matrix M, what I get is that the reduced row echelon form of M, is the identity matrix. So what does that tell us? What that's telling us is that hypothetically, if I would have had added a 0 column here, that there is in fact only a unique solution to this system. So what I can say is that since the reduced row echelon form of M is 1, 0, 0, 0, 1, 0, 0, 0, 1, the kernel of T is just the 0 vector, and T is injective. Alright, great. In the next video, we'll take a look at something that's not injective.